we discuss the magnetic material. Introduction. Material magnetized by the application of external magnetic field. Material जो है वो magnetized करता है external magnetic field को, such as iron, nickel, cobalt. All substances are magnetic to some extent. First three types listed above are so feebly magnetic that they are usually called non-magnetic. Types of magnetic material. There are 5 types of magnetic materials. First of all, diamagnetic. Second, paramagnetic. Third, ferromagnetic. Fourth, ferromagnetic. And next, antiferromagnetic. First of all, paramagnetic materials. Paramagnetic materials are small positive susceptibility. ये जो है small positive susceptibility होती है. No magnetic properties when external field is removed. कोई magnetic properties नहीं होती जब external field खत्म हो जाती है. All electrons are unpaired. तमाम जो electron है वो unpaired है. Permeability is greater than 1, exhibited by solid, liquid and gases. Theory of paramagnetism. Curie law found susceptibility is inversely with absolute temperature. Curie law जो है वो susceptibility को found करता है जो inversely होता है absolute temperature के. Some material not follow this then Curie-Weiss law. Increased temperature, जब increased temperature होगा, increased agitation, decrease the susceptibility. Saturation occur होती है if A is equal to mu H over KT at small a. M varies linearly with H. जब हमारे पास A small होगा, जो M है ना वो very linearly होगा H के साथ. पैरामैग्नेटिक मटेरियल ओबे क्यूरी लॉ. पैरामैग्नेटिक मटेरियल जो है वो ओबे करता है क्यूरी लॉ को विद स्मॉल वैल्यू ऑफ थीटा, जो थीटा की बहुत ही कम वैल्यू को. नेक्स्ट इज डायमैग्नेटिक मटेरियल. Diamagnetic material are weak and negative susceptibility. No magnetic properties when external field is removed. All electrons are unpaired. Realignment of electron path under external magnetic field. Permeability is always less than unity. इसकी जो है permeability जो है वो always less than unity होती है, accepted by ये solid, liquid and gases होती हैं. Third is ferromagnetic. When magnetic force is applied, जब हम magnetic force को apply करते हैं, the domain becomes aligned to produce strong magnetic field within a part. Few substances are ferromagnetic. कुछ जो है substance वो ferromagnetic होते हैं, जैसे कि iron हो गया, cobalt हो गया, nickel हो गया. Ferromagnetic हमारे पास क्या होते हैं? In antiferromagnetism, the two sublattice were equivalent. जो दो sublattice होते हैं वो equivalent होती है. If there is some crystallography reason, the magnetization of two sublattice may not be equal and opposite. जो दो lattice की magnetization है वो ना equal होती है ना opposite, therefore will not cancel, ना ही कि वो cancel की जाती है. The material will then have net magnetization. This phenomena is called ferromagnetism. Application of ferromagnetism is antenna हो गया, transformer हो गया, microwave components, high frequency and sensor. Antiferromagnetism, if the exchange interaction is negative, अगर हमारे पास interaction negative होगी, J less than 0 होगा. अगर हमारे पास interaction positive हो जाएगी तो J greater than 0. The molecular field is orientated such that it is favorable for nearest neighbor magnetic moments to lie antiparallel to one another. जब ये हमारे पास एक favorable होगी जो कि nearest neighbor magnetic moment के साथ जो लाई करेगी antiparallel एक दूसरे के साथ, this is called, इसे हम कहते हैं antiferromagnetism. Types, there is a large number of ways of arranging an equal number of up and down spin as a lattice. There are 2 types, 4 types in a simple cube. इसकी जो है 4 types होते हैं simple cube में, 3 types in a BCC. Next is magnetic moments and angular momentum. A current loop occur because of the motion of one or more electrical charge. जब current loop हमारे पास occur होती है motion of one or more electrical charge पे, all the charges which will considering associated with a particle, जो तमाम charges हैं उसे हम consider करती हैं particle that have mass, जिसका mass हो. There is also orbital motion of mass as well as charge in all current loop in this book. There are 2 effects, Einstein-de Haas effect and Barnett effect. Unmagnetized ferromagnetic rod is suspended by thin fiber along its axis. Initially, rod is at rest and unmagnetized and subsequently magnetized along its length. Next is magnetic field. Magnetic field is a vector field मैग्नेटिक फील्ड जो है वो एक वेक्टर फील्ड होती है दैट डिस्क्राइब द मैग्नेटिक इन्फ्लुएंस ऑफ इलेक्ट्रिक चार्ज, जो डिस्क्राइब करती है मैग्नेटिक इलेक्ट्रिकल चार्ज के मैग्नेटिक को इन रिलेटिव मोशन में। एंड मैग्नेटाइज्ड मटेरियल अ चार्ज दैट इज मूविंग पैरेलल टू करंट, चार्ज जो है वो मूव करता है करंट के पैरेलल ऑफ अदर चार्जेस, बाकी चार्जेस की निस्बत। एक्सपीरियंस ऑफ फोर्स, जो इसकी फोर्स होती है वो परपेंडिकुलर होती है इट्स ऑन वेलोसिटी। वर्किंग ऑफ मैग्नेटिक फील्ड व्हेन इलेक्ट्रिक चार्ज ट्रेवल, जब इलेक्ट्रिक चार्ज ट्रेवल करती है द मैग्नेटिक फील्ड जनरेट्स होती है एज इलेक्ट्रॉन that spin and move around become magnetic object themselves. Elements that have unpaired electron, इसके जो elements है वो unpaired electron होते हैं the ground state में such as iron, cobalt and nickel. Now, magnetization and field. Magnetization is defined as the magnetic moments per unit volume. M can be considered to be a smooth vector field. Magnetization जो है वो consider की जाती है smooth vector field में continuous everywhere except at the edge of the magnetic solid. In free space, in vacuum में there is no magnetization, कोई magnetization नहीं होती. The magnetic field can be described by the vector field. Magnetic field जो है वो describe करती है vector field B and H which are linearly. In magnetic solid, the relation between B and H is more complicated. Magnetic solid में जो relation होता है B and H का वो ज़्यादातर complicated होता है and two vector field may be very different in magnitude and direction. जो दो vector field होते हैं वो उनकी magnitude and direction different होती है. In special case, magnetization is related to magnetic field. Such solids are called linear matter. Next is classical mechanics and magnetic moments. Here we describe the effect of applied magnetic field. हम जो है यहाँ पे describe करते हैं applied magnetic field के effect को on a system of charge, जो कि किसी भी charge के system पे use करते हैं purely classical arguments. First we consider the effect on a single charge. हम consider करते हैं single charge के effect को. This result evaluate the magnetization of system of charge. Canonical movements. In classical movements, the force on a particle, classical mechanics में जो force होती है वो on a particle with charge q moving with velocity v and electric field E and magnetic field B. F is equal to qv E plus B and is called Lorentz force. With similar equation, one shows how the momentum of charged particle in a magnetic field is modified. Where V is the electric potential, A is the magnetic vector, and potential, and W is M is the mass of the particle. Quantum mechanics of spin, orbital and spin angular momentum. The angular momentum of electron associated with the orbital motion of electron around the nucleus is called orbital angular momentum. वो कहते हैं angular momentum of electron, किसी भी electron के angular momentum को associate करता है जो orbital motion of electron के around the nucleus, nucleus के इर्द गिर्द, उसे कहते हैं orbital angular momentum. Quantum mechanics of spin, the components of angular momentum along fixed axis is m1 and magnitude is L is equal to L plus 1. Magnitude of the total magnetic dipole moment is L is equal to L plus 1 mu. Chapter 3, environment. Crystal field theory. Origin of crystal field. The crystal field is an electric field. Crystal field जो है वो electric field होती है derived from the neighbor atom in the crystal, जो drive होते हैं किसी भी atom के करीब crystal में. In crystal field theory, the neighbor orbital are modeled as a negative point charges. Orbital जो है वो model करते हैं negative point charges को, and important on this approximation is line of field theory, which is essentially the d orbital fall into two classes. Orbital which point between the x, y, z axis. Orbital जो है t orbital जो है वो point करता है x, y, z axis को. These are the dx, dy, dz orbital. The Jahn-Teller effect. Jahn-Teller effect, the magnetic properties themselves can influence the symmetry of the local environment. जो magnetic properties होती है वो themselves होती है symmetry के local environment में. For example, octahedron symmetry is distorted spontaneously because the elastic energy is balanced. क्योंकि elastic energy जो है वो balance होती है electronic energy की वजह से due to distortion, किसी ताकि कोई खलल पैदा ना हो. This phenomenon is known as Jahn-Teller effect. We have discussed in Jahn-Teller effect. There are two types: static Jahn-Teller effect and dynamic Jahn-Teller effect. Static Jahn-Teller effect because the distortion which spontaneously occur is fixed on a particular axis of octahedron. and dynamic Jahn-Teller effect. The distortion can switch off from one axis. जो डिस्टॉर्शन होती है वो स्विच हो जाती है एक एक्सिस पे टू अनदर एट हाई टेम्परेचर, किसी भी एक ज्यादा टेम्परेचर पे, गिविंग राइज टू डायनामिक Jahn-Teller effect. Another type of dynamic effect involves rapid hopping of the distortion from side to side. ये जो है किसी भी another type of dynamic effect, किसी और type dynamic effect की कोई और type जो involve होती है distortion from one side to another side पे. And next is techniques to study environment. And we have studied environment. There are three techniques: magnetic resonance, Mossbar spectroscopy, mu spin rotation. मैग्नेटिक रेजोनेंस में जो है वो पहला आ जाता है एनएमआर। एनएमआर क्या होता है, हमारे पास न्यूक्लियर मैग्नेटिक रेजोनेंस होती है। न्यूक्लियस अब ये अब्सॉर्ब करती है लोकल मैग्नेटिक फील्ड अराउंड एटॉमिक न्यूक्लाई को। एंड सेकंड इज ईएसआर। ईएसआर स्टैंड फॉर इलेक्ट्रॉन स्पिन रेजोनेंस, electron spin resonance study of unpaired electrons. And second is Mossbar spectroscopy. Mossbar spectroscopy is based on Mossbar effect. It is discovered by Rudolf Moss 1958. It consists of recoil emission. Muon spin rotation क्या होता है? It is a half spin rotation, a half spin rotation. And thank you so much.